Have you ever wondered how a computer actually remembers something like a customer's name or a sales total? Well, it's not magic. In this explainer, we're going to dive into the absolute fundamentals of the AL programming language. By the end, you'll know exactly how to tell the computer what to remember and what to do with your data.
So here's our game plan. We're going to start with the basics, how to name things and where to store them. Then we'll get into the rules of the road. And finally, we'll talk about the best practices that'll help you write clean, professional code. All right, let's jump right in.
Before you can write a single line of code that does anything interesting, you've got to understand the first step. How do we tell the computer what to remember? It all comes down to giving our data a name and a place to live.
I mean, really think about it. How does a computer hold on to information? The secret is that we create a connection, a link between a name that we can understand and a specific little spot in the computer's memory. That's the whole trick right there. Okay, first up, we have this thing called an identifier. And honestly, it's just a name. That's it. Imagine you're organizing a bunch of storage boxes. The label you slap on the front, winter coats or old photos, that is the identifier. It tells you what's inside, plain and simple. So if the identifier is the label, then the variable, well, that's the box itself. When you declare a variable in your code, what you're really doing is telling the computer, hey, go grab an empty box for me. You're reserving a little piece of memory. The identifier is just the label we use to find that specific box later on. Now, just like any language has grammar, AI has its own rules for how you create these names. In programming, we call this syntax. And trust me, you can't just make up your own rules. Following the syntax is what guarantees the computer understands exactly what you mean.
So what are these rules? Well, first off, every name has to be unique in its area. You can't have two boxes labeled old photos in the same closet, right? Same idea. Second, every name has to start with a letter or an underscore. And here's a pro tip. Even though AL doesn't care about capital letters, you should always use Pascal case. It's the industry standard and makes your code way easier to read. You might be wondering, but wait, what if I really need a name that has a space in it? Like, when was it? Good question. The rule is simple. If you do that, you have to wrap the whole thing in double quotes. That tells the system, hey, treat all of this as one single name. And this shows that difference perfectly. On the left, you see customer name. That's clean, standard Pascal case. Easy. On the right, customer name works, but because of that space, you're forced to use quotes. The best practice? Just stick with Pascal case whenever you can. It'll make your life easier.
Okay, so we know how to label our storage boxes. Now let's talk about how we actually create them in our code. This process is called declaring a variable, and there are a few key ingredients we need every single time. Right, so every variable has four essential parts. We've got the identifier, that's the name, but we also have to define its scope, which is where it's allowed to live. Then there's its data type, what kind of stuff it can hold, and finally, its initial value. So let's break down what scope means first. Scope is all about who can see and use your variable. A global variable, that's like a big public whiteboard in an office. Anyone can walk up and change it, which, as you can imagine, can get messy and cause problems. A local variable, though, that's like a personal sticky note on your own monitor. It's private, it's safe, and it's almost always the recommended way to go. What's really cool is that the system also gives you some special pre-made variables to work with. For instance, when you're working with a table of data, you automatically get rec and xrec. Rec represents the current version of the data, while xrec is a snapshot of what that data looked like before any changes were made. Super useful for tracking updates. So, a variable can't just be an empty box with a label. We have to be specific. We have to tell it exactly what kind of information it's going to hold. Is it for a number, a piece of text, a true or false value? This is what we call its data type. Now, here's a fantastic feature in AL. When you create a variable, the system automatically gives it a sensible starting value. This is called initialization. As you can see here, an integer variable starts at 0, a text variable starts as an empty string, and a Boolean starts as false. This is a huge help because it ensures your code always starts from a predictable, safe state. No surprises. Modern AI has made our life so much easier. In the old days, you had to declare every single variable on its own line. It was tedious, and it made your code files incredibly long and hard to read. But now, check this out. You can declare multiple variables of the exact same type on a single line, just by separating them with a comma. It seems like a tiny change, but it makes your code so much shorter and easier to read.
It's a game changer for keeping things organized, especially in larger projects.
Okay, so we've covered all the individual pieces: identifiers, variables, scope, data types. Now let's pull it all together and talk about one of the most important principles for structuring your code like a professional.
If you take away one thing from this, let it be this. Do not put all your complex calculations and business rules directly inside a page or a table. Instead, you need to put that logic into a separate object called a code unit.
And why is this so critical? Well, for one, it makes your code reusable. You write it once and you can call it from everywhere. It also centralizes your logic, which is a lifesaver for maintenance. Imagine having to change a tax calculation in just one place instead of hunting for it in 10 different files. This also cuts down on bugs from copy-pasting code, and it even helps with security. It's a huge win all around.
Finally, let's quickly touch on a more advanced concept: protected variables. The best way to think of these is like a secret handshake. They let a base object, like a page, securely share some information with an extension that's built on top of it, but without making that information public to the whole world. It's a very safe, controlled way for different parts of your code to talk to each other.
And there you have it. Those are the fundamental building blocks of the AL language. Now that you have this solid foundation of identifiers and variables, you are ready to start building some seriously powerful business logic. So the only question left is, what will you build?